percent composition is just like any other percent you've ever done. Way back when you were learning percents, let's say you had a pile of marbles and 3 of them were red, and then there were 10 marbles total. You would have 3 divided by 10 marbles, and never forget to multiply by 100%. So that would end up giving you 33.333333%. So it's just like that. Body mass index works that way. Batting average works that way. It's just whatever you're looking at over the total number of tries or over the total amount that's there. So we are just doing that for these elements, and we're doing it using their molar masses off the periodic chart. So I've got a periodic chart over here. I've got carbon, and its molar mass is 12.01 grams per mole. And then I'm going to go ahead and say oxygens because it's just on that same chart at the top, 16.00 grams per mole. Now I'm going to do hydrogen. It's over here on the chart, right there. 1.01 grams per mole. And then because there are 6 carbons, I multiply that times 6 moles. There are 12 hydrogens, I multiply that by 12 moles. And there are 6 oxygen times 6 moles. So again, that number is because that subscript. This number is because of this subscript. And then this number is because of this subscript. So this should all be pretty familiar on how you add something up. When you put that in the calculator, I already put it in, you're going to get 180.18 grams per mole. And this right here, this is in 1 mole, it's the molar mass of C6H12O6. That's the mass of that amount right there. All right, so we're going to say this is the whole thing, and if we want to know the percent composition, what we want to find is either the percent of carbon or of hydrogen or of oxygen. You might have to do some of them, or you might have to do all of them. Make sure you're reading the problem, because if it's only asking you for carbon's percentage, then don't also go ahead and waste your time solving for these ones. All right, so this is our bottom number, 180.18 grams per mole. And then my carbon, so if we're doing percent carbon, that's 12.01, that's grams per mole, times, I can't just do 1 carbon because you'll notice there are 6 carbons in there. So I've got to do all 6 of them in there. And then, don't forget, times 100%. With these, if you get something that doesn't look like a percentage, you get like 0.001, like go back and double check your formula, because they should look like percentages. 12.01 times 6 divided by 180.18 and times 100. Notice I just do it all at once, and that gives me 39, and I'm going to go with this one right here, 39.99. And sig figs on these are actually a little tricky. Or maybe I should say most people don't care as much about the sig figs of these. Some people do. So this one has 1, 2, 3, 4, so we'll go with that. Now if I want to know the percent hydrogen, and again, make sure you're solving for what the problem asks. Don't do extra work. 1.01 grams per mole, that's the hydrogen, times the 12 moles of hydrogen, and then it's got the same mass on bottom because that's the mass of the molecule that it's in, times 100%, so 1.01 times 12, and then divided by 180.18 and times 100. If you prefer to do all the multiplying and then the dividing, I often do it that way. You can do it that too. All right, so I've got 6.73%. Notice that has 1, 2, 3 sig figs. And then I'm going to do my percent oxygen, which is 16.00 grams per mole, times 6 moles over 180.18 grams per mole, times 100%, equals 16. You don't have to put the 0.00. Times 6 divided by 180.18 times 100. gives me 53.28%. Now, there's another way that we could also have gotten to this one, and it's the idea that this is 100% of a molecule, and so the parts should add up to 100%. So we could have also solved this one saying that 100% minus 39.99 minus 6.73. So I took this number and this number. 100 minus 39.99 minus 6.73. And I get 53.28%. So I could have skipped this if I was feeling like skipping it and have just kept up with the math of it. That's fine too. But I'm just letting you know, once you get to the very last one, you can use this little relationship. But you can't do it until you've already done these other two.